All right, guys, so this video is going to go ahead and finish up the notes from yesterday. We're going to be looking at exterior angle theorem to start off, and then we'll go into notes 4.3 going into congruent triangles. So to finish up yesterday's notes, exterior angle theorem, for us to begin understanding how this works, we need to be talking about interior versus exterior angles. Interior angles, these are going to be angles that are located on the inside of the triangle, okay? Exterior angles is going to be all of the angles that are located on the outside of the triangle. And these exterior angles, typically what you'll notice in the problems that we do, these will be angles formed by one side of a triangle and an extension of an adjacent side. Okay, so we have an example off to the right here, and we'll kind of be able to recognize what these interior versus exterior angles are actually going to be. So if we look at the diagram off to the right, we see that we have the interior, the exterior. Here, it's very clear that angles 1, 2, and 3 are going to be our interior angles. In this scenario, angle 4 is going to be our exterior angle, and this is what is being described in that definition. This exterior angle, angle 4, is being formed by one side of the triangle, which I'm just going to highlight here in green. This side of the triangle right here. So it's being formed by this side of the triangle and an extension of this other side that is adjacent to it. So that's how these exterior angles are formed, and you'll kind of get more familiar with them as we start to do some examples. They pretty much look very similar, okay? So that covers interior versus exterior angles, and then what we're going to talk about now is remote interior angles. This concept is extremely important to understand, okay? So as we look at remote interior angles, these are going to be interior angles that are not adjacent or next to the exterior angle. So if I'm looking at remote interior angles, okay, this is the interior angles not next to the exterior angle. So if I look here, my remote interior angles are going to be angles 1 and angles 3. Okay, notice that these angles are in the interior and they are not directly next to that exterior angle. So fill in the blanks here, we see that angle 1 and angle 3 are going to represent our remote interior angles. Super important to understand. I like to think of the word remote, like if you think of a remote island, you think of it as being kind of very far away, kind of off someplace. So these remote interior angles are these angles that are far away from that exterior angle, as far away as possible. And so now we get to the exterior angle theorem. Okay, the exterior angle theorem is going to be us looking at, and it'll make more sense looking at this diagram after reading this definition, but the exterior angle theorem is the measure of an exterior angle of a triangle. That exterior angle will be equal to the sum of the two remote interior angles. So if I look here, I'm just going to kind of highlight here. If I add up my two remote interior angles, then the sum, when I add those up, that is equal to the exterior angle. Okay, and we'll see how that works. And like I said, as we start to look at some more examples, you'll become more comfortable with this. But the idea here is this: exterior angle theorem states that you add the two remote interior angles, and that is equal to the exterior angle. So we'll look at some examples here. Example 4 says, find the measure of angle JKL. So if I'm looking at this diagram here, we can see here that angle J, the measure of angle J, plus the measure of angle K is equal to the measure of angle L. This is going to be our exterior angle theorem in action. So here is one remote interior angle. Here is another remote interior angle. Those two remote interior angles will add together to equal the exterior angle. So here's my exterior angle. So setting this up just really quickly, we have 6x plus 8, my first remote interior, plus 9x plus 7, my second remote interior angle. That is going to be equal to the exterior angle, which is 10x plus 40. Okay, just setting that equation up, we can solve now. If I combine like terms, 6x plus 9x is 15x, 8 plus 7 is 15, and then we have 10x plus 40. If I solve for x here, I would subtract 10x on both sides, leaving us with 5x plus 15 is equal to 40. Subtract 15 on both sides, we get 5x is equal to 40 minus 15 is 25. If I divide both sides by 5, then we get 25. Okay, sorry, 25 divided by 5. If we divide both sides by 5, we get 5 as our value for x. And like I always kind of try to remind you guys, after you find x, go ahead and read the question just to make sure that you've answered it. Here it's asking you find the measure of angle JKL. And so now we're going to kind of briefly go over how is it that I identify angles, because we haven't really seen angles with 3 letters very often, at least recently. So remember that K, that middle letter has to be the vertex. So JKL would be this angle right here in purple. So the measure of angle JKL is going to be represented by 9x plus 7, where x we found out to be 5, so 9 times 5 plus 7. 9 times 5 gives us 45, and if we add 7, we get the measure of angle JKL, which is 45 plus 7 to get you 52, right? And because we are talking about the measure of an angle, we want to make sure that the units are appropriate here, 52 degrees. Okay, we'll look at another example here. Okay, another exterior angle theorem problem here. So it says find y and z. What you'll notice here is that when I look at this diagram, I see here that these are remote interior angles with the 135. The only issue is if I add those two remote interior angles, I have a y and a z, and I'm not really able to solve with that. Okay, so our approach has to kind of be a little bit different here. What hopefully you guys are seeing is the fact that this angle 135 degrees forms a linear pair with the angle that is adjacent to it. So if I want to find that adjacent angle to 135, that's a linear pair, we do 180 minus 135, and we see that that gives us an angle measurement of 45 degrees. So that tells us, hey, this angle right here, 45 degrees. And now we can take a look at our exterior angle theorem with the y's here. So this, I guess let me circle it since that's going to be a little hard to read. Our remote interior angles, when I'm solving for y, I see here that I have a 5y plus 5 and 45. These are the remote interior angles to the exterior angle 9y minus 2. So we simply just add those up. We have 45 plus 5y plus 5 is equal to 9y minus 2. Here we just solve for x. If we combine like terms here, we have 45 plus 5, so we get 5y plus 50 is equal to 9y minus 2. Subtract 5y on both sides. We get 50 is equal to 4y minus 2. Add 2 on both sides. We get 52 is equal to 4y. If I divide both sides by 4, 52 divided by 4 would be 13. So 13 is equal to y. So we found y, but go ahead and understand that not only were they asking you for y, they were also asking you for z. So a couple of different approaches we can take here. We can do the exterior angle theorem with the 5y plus 5 and the 4z plus 9. So let me erase and show you what I'm talking about here. Hold on, let's get that back up there. So if we look at what we have currently, okay, we know that that angle is 45. What I was trying to say here is that you can do these two remote interior angles and add those up and set it equal to 135, or we can use what we learned about yesterday, understanding that the three angles inside of a triangle have to add up to 180 degrees. If we found out that y is 13, okay, we'll just do this mental math really quickly. 5 times 13 plus 5, 5 times 13 is 65 plus 5 is 70. So this angle here at the top is 70 degrees. So if I want to represent and find out what 4z plus 9 is, I know that these three angles inside the triangle have to add up to 180. So 45 plus 70 plus that angle 4z plus 9 has to equal 180 degrees because, like we said yesterday, the three angles inside of a triangle add to 180. Okay, so it's just another way of solving this. 45 plus 70 plus 9, if we combine those like terms, 45 plus 70 is 115. 115 plus 9 is 124. So we get 4z plus 124 is equal to 180. If I subtract 124, we see that 4z is equal to 180 minus 24 is going to give us 56. From here, if we divide both sides by 4, we get that z is equal to 56 divided by 4. Half of 56 is 28, 14, so half again is 14. So z is equal to 14. Okay. You could have also done the value of z by using the exterior angle theorem. You will get the same answer, z is equal to 14. Okay, so just to recap here, your exterior angle theorem, you add the two remote interior angles and set it equal to the exterior angle. All right, what we're going to move through on right now is going to be the notes for 4.3. Okay, so the notes for 4.3 is going to be covering congruent triangles. And so to start off here in the first blanks, in two congruent triangles, all of the parts of one polygon are congruent to the and this part's important, corresponding parts of the other polygon, okay? And we've already talked about corresponding before. Corresponding, we said matching position in the past chapter. So really what you want to hone in on here is in two congruent triangles, corresponding parts are congruent. Okay, I know I'm kind of like reading that in a different order, but what's highlighted there is what you need to know about congruent triangles. Congruent triangles have corresponding parts that are congruent, okay? And what I try to do is color code this here for you so that you can see how that works visually, okay? So if I look at the following, and this is called a congruency statement, okay? This is a term that is going to be used often throughout this chapter. So if they ask you a congruency statement, you're writing a statement that says that two objects are congruent, right? Hence congruency statement. So if I'm looking at triangle HAM is congruent to triangle PIG, then we're looking at the corresponding parts that are congruent. So in this case, angle H would be congruent to angle P. Similarly here, if I look at the letter A is in the middle. The letter that it corresponds to in the second triangle in the middle is I, so angle A is congruent to angle I. And then lastly here, we can take a look at angle M, which is the last letter, is congruent to the last letter in this second triangle. Okay, so pretty much just a matching game with these congruent triangles. You're just matching up the corresponding pieces here and understanding that those corresponding pieces will be congruent. This applies not only to angles, but to side lengths as well. Okay, I'll kind of show you how this works with side lengths. If I look at HA, which I have highlighted in yellow, HA is the first two. So it corresponds to the first two in the second triangle, which is PI. So we could say here that HA, line segment HA, is congruent to line segment PI. Okay. Similarly here, if we take a look at the second and third letters, so if I take a look at AM, that's the second and third letters. It corresponds to the second and third letters, which would be IG. So in this case, line segment AM is congruent to line segment IG. Okay. And then lastly, we've done first and second, second and third. Now we can do first and last. HM, well, that's the first and last letters. It corresponds to PG. So we can say here that line segment HM from that first triangle is congruent to line segment PG. And that's how these congruent triangles are going to work. These corresponding angles will be congruent and the corresponding sides will be congruent. So we'll look at an example just and kind of breeze through this a little bit faster now that we kind of understand what's going on. So in the diagram, triangle ABC is congruent to triangle DEF. Complete each statement below. Okay. In the previous example that we did, it's pretty obvious to understand here because the orientation is the same. If I look here, this angle H would be congruent to angle I. Angle A is congruent, sorry, I said that wrong. Angle H is congruent to angle P. Angle A is congruent to angle I. And then lastly, angle M is congruent to angle G. And I want you to notice too how I'm matching these markings, right? One ring for H and P, two rings for A and I, three rings for M and G. You need to be able to differentiate them, but still kind of show that in the different triangles are congruent. So the point I'm trying to make here is this. We can see this very easily visually by looking at the triangle. But what I want you to rely on, if they give it to you, if they give you the congruency statement, this is what you should rely on and be using every single time to find out your corresponding matching congruent parts. So if I look at BC, BC is going to be the last two letters, so it corresponds to EF. So BC is congruent to EF. Okay. Again, I think we understand the idea here. I'm not going to sit here and kind of color code and highlight every single thing. F is the last angle in the second triangle, so it corresponds to C. So F is congruent to C. A is the first letter. It's congruent and corresponding to angle D. And one thing I do want to notice, and we'll talk about it here, measure of angle E. E is the letter in the middle, so it corresponds to B, which is the letter in the middle in the other triangle. Pay attention to this here and highlight this in your notes. Notice that whenever I have congruent, I'm just using angle when I'm talking about angles. So congruent, we use an angle symbol, but if I say equals, now we actually have to say the measure. Okay, so just be mindful of that because the notation is similar but not exactly the same. So you use the measure of an angle. If you say measure of an angle, you write an equal sign. If it's just plain old angle symbol like we have in pink, you use a congruent symbol. Okay, well, we'll go ahead and keep going here. DF is going to be the first and last letters of the second triangle. So DF. So it corresponds to first and last here, AC. So, and one thing you'll notice here is that this doesn't have the bar on top. Very similar situation to what we had earlier, okay? We're talking about the angles. If I have a congruent symbol, that is when you utilize the bar on top of the line segment. When we have equals, on the other hand, if I have equals does not have a bar on top. Okay, so just understanding when to put a bar and when not to. You use the bar on top for congruent, you do not use the bar on top for equals. Okay, and now we go ahead and complete the congruency statement. This part F is having us write the congruency statement. And we have the congruency statement circled here in example 1. Triangle ABC is congruent to DEF, but look at how they shifted the order. Okay, it says now ACB. Okay, so it goes, if I'm looking at this part right here, ACB is first, third, second. So it corresponds in the second triangle to first, third, second, which would be triangle DFB. Okay. And so as we start looking at congruent triangles, we want to go ahead and talk about a theorem here known as the third angle theorem. The third angle theorem states that if two angles of one triangle are congruent to the corresponding angles of another triangle, then the third angles are also congruent. And this is depicted here in the picture below. So here I have two pairs of corresponding angles that are congruent. That's one pair. Here's a second pair. That would then imply that the third pair of angles there would have to be congruent. Okay, so that's known as the third angle theorem. And this is sometimes utilized throughout proofs, which we will be looking at again this chapter. So here in the next problem, it says, find the measure of angle DCN if the measure of angle R is 75 degrees. Okay, so angle DCN is this angle right here. Okay, this is the angle we're looking for. And they tell us that the measure of angle R is 75 degrees. So the measure of angle R here, 75 degrees. Okay. What you're going to end up noticing here is that, and this set of notes is talking about congruent triangles. So, and the whole point of us having this here is you'll notice that there is no congruency statement, right? There is no congruency statement. So how do I know these triangles are congruent? Well, we just talked about the third angles theorem. If you look at point N here, we'll see here is going to be a pair of vertical angles, right? So what we're seeing here is the third angles theorem in action, okay? Here I have one pair of angles that are congruent, and here I have a second pair of angles that are congruent, okay? The third angles theorem states that if you have two pairs of angles that are congruent, then that implies that the third pair of angles must also be congruent. So that would imply here that these two angles would be congruent, making angle DCN, the measure of that angle, would have to be also 75 degrees. Okay, so that's the third angles theorem in action. If we go ahead and move on, we'll look at some solving questions now. So it says if the measure of angle DEF is congruent to the, if triangle DEF is congruent to triangle PQR, and DE is 3x minus 10, QR is 4x minus 23, PQ is 2x plus 7, and EF is equal to y, then find the value of x and y. When you read that all at once, it's a mouthful. So look at this and chunk this up and start looking at these corresponding pieces. If I look at DE, DE corresponds to PQ. So I know that those are congruent. In other words, those are going to be equal. So if I take a look here, do they give us DE and PQ? In the problem, we see that they do. We need to understand here that DE is going to be equal to PQ, okay? Because they told us that these triangles are congruent, so DE is congruent to PQ. That's sufficient to say that they're going to be equal. So that's going to be how we set up our equation, at least to start off here. So we have 3x minus 10 is equal to PQ, which is 2x plus 7. You want to make sure you're reading this carefully because it's easy to make a mistake. So if you want to like box this in, I guess, just to kind of chunk it a little bit easier, because even me reading this right now, I'm starting to have like a dyslexic moment here. So if we have that equation set up where DE is equal to PQ, we're left with 3x minus 10 is equal to 2x plus 7. Here, just solving for x, we minus 2x on both sides. We get x minus 10 is equal to 7. If I add 10 to both sides, we get that x is equal to 17. Okay, but if I look at this question, it said find the value of x and find the value of y. So let's focus our attention on y. Okay, if I look at y is represented by EF. So if I look at EF here, EF, what corresponds to and what is congruent to EF? The answer to that would be QR. So we would understand here that EF is equal to QR. Well, EF is Y, okay? So EF is Y, and QR is 4x minus 23. All we're doing now is just plugging those values in. So EF is Y, that's equal to QR, which is 4x minus 23. So there's the setup. And we already found out what x was, so 4 times x, which is 17, minus 23. 4 times 17 is 68, and if I subtract 23, we see that y is equal to 45. All right, okay. So again, these congruent triangles, it's really just a matching game. Hopefully this is making sense. And kind of the acronym that we have for basically the entire kind of basis around today's notes is we have to understand the following. This part is extremely important. Corresponding parts of congruent triangles are congruent, right? Which sounds like a lot, but this is summarizing what we've talked about, okay? If I have congruent triangles, then their corresponding parts are congruent. That's what's being communicated in this statement. The acronym that we use for that is CPCTC. If you write that, I can understand that what you're telling me is what is highlighted here in blue. So what we'll take a look at here is example 4. We just have another kind of example where we got some expressions here, but we're potentially asked to solve for x or an angle, something along those lines. So it says triangle LMN is congruent to triangle JKL. If the measure of angle M is 5x minus 2, angle J is 1/2, parentheses 2x minus 28, and K is 1/3, 6x plus 42, then find the measure of angle L. Okay. I'd encourage you to try to do this without a calculator. We do have some fractions here, but we'll kind of go through and see how we're going to manage those fractions when we distribute. So I'm going to start with what I'm given here. Okay, I'm given angle M, angle J, and angle K. I'm going to start with angle M just because that's the first one that I see. Angle M, if I look here, angle M is the middle letter, so it's corresponding and congruent to angle K. Which angle K, so here's M, angle K is right here. That indicates that these two angles are going to be equal, so I would set that up. We got 5 parentheses x minus 2. Let me just write this off to the side here, that way in case you look back at your notes later, you understand what's going on here. Angle M is congruent to angle K is what we're saying. So if they're congruent, that means that those angles are equal to each other. We got 5 parentheses x minus 2 is equal to angle K, which is 1/3 parentheses 6x plus 42. From here, if I distribute, we're looking at 5 times x, which is 5x. 5 times negative 2 is negative 10. If I distribute this 1/3, 1/3 is essentially the same as just dividing by 3. So this would be 1/3 times 6x would give us 2x. 1/3 times 42, that would be 14. Here, solving for x, we subtract 2x on both sides, and we would just doing all these in one step. This would cancel, which I guess, let me not do that since I just made not a mistake, but this is just going to make it more annoying to work with. If you're going to do this, this is fine. Just be careful. I just caught myself making mistakes, so let me just do this in separate steps instead. I got 3x minus 10 is equal to 14. I should not have subtracted the 14. I should have added the 10 instead. Doing so would have given you 3x is equal to 24. If 3x is equal to 24, then dividing by 3 tells us that the value of x is going to be 8. Okay, I'm going through this pretty quickly, just at least the solving part, just because we should be comfortable solving equations like this. Now, every time you find x, please reread the question to make sure you've answered it. It says find the measure of angle L. So angle L is, let's take a look. Angle L, notice that in the description I have M, J, and K. They didn't give me angle L. But I do know here that angle L is the last letter, so angle L has to be congruent to angle M. And now I'm realizing that this is going to be a little bit extra work. Okay, so we have to understand the following here, that in this case here, angles M and K and L is what we're looking for. With the way this is phrased, there's not enough information to actually find the measure of this missing angle. So why don't we change this to, let's find the measure of angle J. Okay. If I give you a problem, you're going to have enough information to solve it. The way that it was phrased right now, we don't have enough information to solve. So go ahead and just change that question to find the measure of angle J. So the measure of angle J here is going to be given by 1/2 parentheses 2 times x, which x was 8, and then minus 28. Okay, here I'm going to go ahead and follow order of operations. Order of operations, PEMDAS, starts with the parentheses first. So I'm going to start with the parentheses. 2 times 8 is 16 minus 28. If we do 16 minus 28, then we get negative 12. And now this is making me see that we may or may not have a mistake. Either the question is flawed or we made a mistake somewhere. Because if I look at the measure of an angle and I get negative 6, then that is not a reasonable solution there. So we set m equal to k. Let me just double check the work here. 5x minus 10 is equal to 1/3 of 6 is 2x plus 14. 3x is equal to 8. J would be 8 times 16. Yeah. Well, this is not going to be a reasonable solution. So what we'll just stop with here is x is equal to 8. Okay, so my mistake. Hopefully that doesn't confuse you guys. Just understand that if you do get an angle that is negative, that's not a reasonable solution, and that's a red flag. Either we made a mistake or the question is flawed and the problem has a mistake with how it's phrased. Okay. What we'll finish up with here is our proof. Okay, so write a 2-column proof, and the given here is kind of a lot here. So I'm actually going to break this up into kind of different pieces here. I'm going to do the given as like individual parts here. So SV is congruent to RV. Okay, so as I write these down, what I'm going to do is I'm going to mark it in the picture. SV is congruent to RV. Okay, they're giving me all this information in the given, and they want us to prove that the triangles are congruent. To prove that triangles are congruent, you need to show that corresponding angles are congruent and corresponding sides are congruent. So here, I can say this because that was given. Statement 2 is going to be the second part of the given, which is TV is congruent to WV. I can say that because that's given, and if I mark that in the picture, TV congruent to WV. Third part of my given, ST is congruent to RW. So these are congruent. And the reason for that is that it's given. And then I want to go ahead and state the fact that ST is, those vertical bars stand for parallel, so ST is parallel to WR. So if they're parallel, that would indicate that these two lines are parallel. Okay, which parallel is bringing us right back off the chapter we just talked about. If these are parallel, then hopefully you guys are able to see that what we have here is a transversal. Okay, so this would be a transversal. And over here in blue, we would have a transversal. Okay, so again, to prove that two triangles are congruent, you need to show that all corresponding sides are congruent and all corresponding angles are congruent. So we can go ahead and start with this right here. Okay, angle SVT, which is the top part of that vertical angle, angle SVT is congruent to angle, the bottom part of that vertical angle would be WVR. The reason why those are congruent is because that would be coming directly from the vertical angles theorem. Okay, theorem because I'm actually writing it that it's congruent. We're not going to write definition for all these just because it's going to be so many statements. We're just going to go straight into the theorem. Next, we can take a look at, let me do this in a different color. Let me do this in green. Next, I want to show that the other three corresponding angles are congruent. If I look here, this angle and the angle that I have marked here would be looking at the purple transversal. Those would be alternate interior angles. So we would say here that STV is congruent to the other angle VWR. And then I need to show lastly that this angle is congruent to this angle, which we're going to use the same reason now, just at the blue transversal. And I didn't write it down here, but we just said this is alternate interior angles. So alternate interior angles theorem, because we wrote congruent. And our statement number 7, looking at the angle located at S and R, which I guess we could probably just name this S and R, but we'll go ahead with the 3 letters like we've been doing. TSV would be congruent to VRW. And the reason for that would be also alternate interior angles theorem. Okay, so what I've effectively shown just now is I've shown that all three sides are congruent and all three angles are congruent for these two triangles. If that's the case, then what we can actually say now is the congruency statement. So now I can show that here, triangle STV is congruent to triangle RWV. Okay, and please just understand here that what we essentially wrote here, and I'm just going to write it off to the side. Here we essentially wrote that angle T is congruent to angle W. Here we wrote that angle S is congruent to angle R. Okay, that way you can kind of see it more traditionally here. T is congruent to R, and then V is congruent to V, which we had from the vertical angles, and then we also just looked at what we did there on the statement number 7, S is congruent to R. Okay, so we'll look at more proofs to kind of a little bit more in detail later on in this chapter, but that's going to be the end of the notes. If there's any questions, please feel free to send me a message in Canvas, and we'll talk about it either via Canvas or when I come back on Wednesday, Thursday, whenever I come back. Sorry. Please rely on one another to get the answer keys. I'm going to leave Ms. Pierce the answer key to the test. She's going to read them out loud. If you miss it, just ask a friend. Please don't make her repeat it like 50 times, but I will see you guys when I come back.